Welcome, dear students. In today's lecture, we will cover up questions on Carnot cycle and what objective questions can be asked in your final examination. We will go through some questions from your paper also, that what questions are asked on Carnot cycle, and we will cover up one by one all these topics, means what they have asked on the Carnot cycle. This question is of November 19. The second question is from May 18, that these questions were asked from the initial topics of Carnot cycle. So what the refrigeration system is, because starting we should know that what the refrigeration system is. Refrigeration, it is a process of maintaining lower temperature, because we know that we used to maintain a lower temperature in our fridge or AC compared to surrounding in order to maintain lower temperature continuously. If you want to maintain the lower temperature continuously, system must run on a cycle, and there are several cycles, whether it is the air refrigeration cycle or vapor compression cycle. Mostly these are the two most popular type of cycles which are generally used. And initially, what question can be asked? The most popular question will be the unit of refrigeration, that is ton. That will be asked, that what 1 ton is, because conventionally that unit ton is used, but in SI system its equivalent is given by 3.5 kilowatt, either 3.5 kilowatt, it is mentioned over here, or 210 kilojoule per minute, because in Khurmi book all questions are solved by converting it into kilojoule per minute. But if you go for the other books which are purely written in SI system, because SI system is more popular, than kilowatt is used. So definition of ton should be known, because what is ton in this? A ton is defined as amount of ice which is being melted from at 0 degree centigrade, means temperature remain constant in 24 hours. We know that we for measuring the heat there are only two formulas. One is mCp delta T, whenever there is a heat, there is a temperature change, and second formula is mass into latent heat. Because what used to happen when a liquid is heated, whatever the liquid is, whichever type of liquid available on the earth is heated, initially its temperature used to rise. If you draw a temperature enthalpy diagram, I have told you earlier also, if the temperature is drawn on y-axis and heat is drawn, enthalpy is drawn on x-axis, then initially temperature will rise and heat will be also consumed. But after a certain time, what used to happen when the temperature reached to a certain limit, what used to happen that after certain time, what used to happen that a horizontal line is obtained, means temperature will not rise, phase change will take place, means phase will change from the liquid to the vapor. So similar is the case whenever phase change is there, means phase change is observed twice. If you are heating from the solid state, then what will happen? In the solid state, if we consider the ice, if we start hitting the ice from 0 degree centigrade, if we start hitting the ice from, suppose we are hitting from -10, from -10 to 0 degree centigrade, it will give increase in temperature. The temperature will increase. From 0 degree solid to 0 degree liquid, it won't give any temperature rise, means liquid. Then again it will give temperature rise, and then liquid to vapor, it won't get any temperature rise. So whenever we get this type of horizontal line, means these lines which are shown over here, we use ML formula, means mass into latent heat. And whenever we get these types of inclined line, we use formula, that is mCp delta T. So here what is happening, the temperature is remaining constant, so we can't use delta T, we use ML, and the formula is mass into latent heat. But the time is also a factor, so we divide it by the time and get the reading in the kilowatt or watt. So the reading which we get is 232.6 kilojoule per minute. It is rounded off, because we can't use this, rounded off to 210 kilojoule. And if we are divided by the time 60, 210 divided by 60, if we divide it 210 with the 60, 210 divided by 60, then we will get 3.5, and this is being shown over here, that the factor is 3.5. Now hereafter, the second important term is coefficient of performance, because in what used to happen, the desirable effect in refrigerator and heat pump. Heat pump is also similar device with the refrigerator also. It is a winter AC. The term COP is used. What COP is? For this, we have to go through these three figures. Means what heat engine is. This is the heat engine. The second is the refrigerator, and third one is the heat pump. So all the systems in thermodynamic, when we study the thermodynamic property, we used to draw only temperatures only. Means take it as a reservoir and a system only. So starting with the first system, that is a heat engine. In heat engine, the term efficiency is used. Efficiency of engine is given by eta. Whereas for refrigerator and heat pump, efficiency is not used. The term which is used is CO and P, COP, coefficient of performance. This is being used. Now what the term are there, because we know that efficiency is defined as output upon input. So the same thing we will use over here. That will be efficiency is defined as output upon input. So what is the output in an engine? We know that output is the work done, and input is the heat supplied from the reservoir, that is the engine cylinder, which used to continuously maintain the temperature by burning fuel. Here all the high temperatures are shown by T2 and all the low temperature are shown by T1. Now if we consider the engine, in engine what used to happen, that engine cylinder is maintained at high temperature. It used to take certain amount of heat. From this heat, two diversions are made. Certain is used for work done and certain amount is rejected to the atmosphere, because second law says that we have to reject certain amount of heat. Second law of thermodynamics says to the atmosphere. Whole heat cannot be converted into the work. So what is the desirable effect? This is the work done. It will be used in the numerator, and the input is Q2. But we know that Q2, which was going in this direction, means Q2 was going in this direction. This is being shown over here. Q2 was going. So if we take as a arithmetic summation, if the energy conversion law we used to apply, then Q2 will be equal to WE, because two diversions are made from Q2. One has gone this side and one has gone this side. This is Q1. So Q2 equal to WE plus Q1 summation of the two. So what will be the WE? WE will be Q2 minus Q1. So we will write, instead of WE, we will write Q2 minus Q1, and the numerator is again Q2. So we will write, if specific heat are assumed constant at all the temperatures, then Q2 can be written as T2. Instead of Q2 we will write T2. The term T2 will be used, and for Q1 we will write T1, the corresponding temperature, and for again Q2, which is mentioned over here, we will write T2. So we have written over here the T2. Now in this way, what used to happen, the efficiency is always less than 1, because if we divide it T2 by T1, it will be 1 minus T1 upon T2. That's why whatever efficiency you get for the engines is less than 1. Either it is 0.7, 0.6, 0.4. So whatever efficiency you are getting, and that too in the case of Carnot efficiency, because this is the maximum possible efficiency if the engine is operating between two temperatures. Suppose if your engine is inside temperature of the engine is very high, it is 1000 degrees centigrade. It means T2 you have to write 1000 plus 273, and atmospheric temperature is low, that is in the month of April the temperature is suppose 35, then 35 plus 273 will be the atmospheric temperature where the heat is to be rejected, and again the T1 is again 1000, means 1000 plus 273. In this way we can obtain the efficiency. Now we are coming to the second thing, that is After heat engine, what the second thing is, that is refrigerator. We know that refrigerator don't use to give work, they used to consume electricity. That's why the arrow is in this direction. Similarly, winter air conditioner also used to consume electricity. That is, in technical we call it as heat pump. Heat pump they have mentioned. And summer we used to call it refrigerator. Refrigerator used to consume electricity. That is being shown. Heat pump also used to consume electricity. Means work is going inside this device. This device name is given over here. So work is going inside it. And what will happen, that in refrigerator we know that the inside temperature of fridge is very low. So it will take heat from cold body and give it to the high body. So that's why in second law one statement is there that it is impossible to transfer heat from low temperature body to the high temperature body without any external aid. And that's why these both the devices are drawn whenever that definition is asked in the examination, the second law definition. Because there are two statements for second law. For one statement, this device is used. This is the Kelvin Planck. And this is the Clausius statement. For this, we used to draw these two figures, refrigerator and heat pump, because it is impossible to transfer heat from low to high without any work done. So two statements are there for thermodynamics, and one figure is for one statement, and these two are for the second statement, because they used to say certain things are impossible. Now what we have to do, the cold temperature body is given over here. The heat is extracted. The heat which is shown is extracted from it, because in our fridge also the heat is extracted. And whatever electricity we used to consume, both of this used to get added over here, means they are added plus. And we used to get Q2. It means what will be the Q2? Q2 will be, what Q2 we are getting will be summation of Q1 plus WR. This is written over here. In this way, whatever heat the AC used to reject in the atmosphere is more. If your room is cooled, whatever heat is consumed from your room or fridge, the heat which will be delivered to the atmosphere will be heat consumed from the room, that is room, whatever heat is consumed from the room, plus electricity will also get converted into the heat, and both of this will be added, and that's why the AC condenser which is placed on your roof or outside used to give too much heat. Too much heat is used to give, because one heat is from the room and other heat is from the electricity. Both are added, and then this heat is rejected to the atmosphere, and too much global warming is created by air conditioners. So similar is the refrigerator is also a type of air conditioner. So in this way, what will be the COP? Because we should know the COP. Here I would like to discuss the heat pump also. The same figure is drawn for the heat pump also, but heat pump used to pump the heat. As the name shows, it is used to pump the heat. If ambient temperature is very low, means you are living in if we are going through December season and the temperature this year was 2 degrees centigrade outside, then this device has the capability to transfer heat from low temperature body to our room, and room will be maintained at high temperature, that is comfort temperature 22 degrees centigrade, means heat will be pumped. So desirable effect of heat pump is how much heat is delivered, and desirable effect of refrigerator is how much heat is extracted. So when we go for the COP of any system, means COP is the term that is used for only these two systems, because for the first we are using the efficiency. So when we are going for the COP is defined as desirable effect, means what is desired. Some writer has given the good definition that it is defined as a desirable effect upon work done. When we see the desirable effect of the fridge, in fridge what used to happen, how much heat is extracted from the fridge, means how much cooling is given to our fridge, cold body. So Q1 will be in the numerator. We have to write the Q1 in the numerator, and work done will be in the denominator. What will be the work done? W equal to, work will remain alone this side on the right hand side. Work will be Q2 minus Q1. So we will write Q2 minus Q1. If again the specific heat is assumed constant and the other parameters are also assumed constant, then instead of Q we will write T, the lower temperature, means whatever temperature is lower, that will be written T1 upon Q2, T2 minus the T1. So we have to learn that whenever a question on COP of refrigerator is asked, COP of refrigerator is asked, then we have to place the lower temperature in numerator. Means if the question is given that his fridge is operating between -6 and the month is of April, so outside temperature is suppose 35. We will convert both the temperature in Kelvin by adding the common term, that is 273, and the lower will be placed in the numerator and the bigger one will be the T2. So this is how we will get the COP of refrigerator. If we are going for the COP of heat pump, in heat pump the desirable thing is not this, means whatever heat is extracted from the atmosphere, this will be not the desirable. The desirable will be the what heat is delivered, what heat is pumped. So in heat pump, the desirable will be the Q2. It will sit in the numerator upon work done. You can see the work done is Q2 minus Q1, means Q2 minus Q1 we have to use. Again, instead of Q we will write T2 and this is the Q2. We will write Q2 minus T1. So in this way we learn that in heat pump we have to place the higher temperature above. Suppose in the winter season heat pump is working and outside temperature is very low. In the December month it is 2 degrees centigrade and we want in our room the temperature of 22. So 22 plus 273 will sit in the numerator and T2 minus T1 means 22 plus 273 minus 2 plus 273 will sit in the denominator. One special thing we should know that from the formula of COP of heat pump, the COP of heat pump is just reverse of efficiency of heat engine. Means if we take 1 upon efficiency of heat engine, we get the COP of heat pump. COP of heat pump, this we should learn because I will give you one question on this COP of heat pump. And again the second thing is that COP of means if the COP of refrigerator is or COP of refrigerator is heat pump COP minus 1 or COP of heat pump, we can write the COP of heat pump. If the COP of heat pump is not known, then the COP of heat pump can be determined if the refrigerator COP is known. If the refrigerator COP is suppose 5, then the heat pump COP will be plus 1, means 5 plus 1 equal to 6. So COP of any one system is to be determined whether it is heat pump or refrigerator. If you know the COP of refrigerator, suppose it is 5, then you can determine the COP of heat pump by adding 1. You will get 6. So this you should know. On this I would like to solve one question also because question is asked. This is the question which is asked in competition exam. Efficiency of Carnot is 0.8. 80% is the efficiency. We know that it is the 0.8. And if the cycle is to be reversed, and what will be the COP of reverse Carnot cycle? Means COP of refrigerator we have to determine. We know that efficiency of heat engine, if we take 1 upon efficiency of heat engine, we will get COP of heat pump. COP of heat pump can be determined, means heat pump COP we will get if we take this. And if the heat pump COP is determined, if we minus 1 from this, we will get refrigerator COP. So what we have to do, we have to take the reciprocal. We will start with the question. The calculator I have opened. We have to first divide 1 divided by 0.8. We have received what? This is the COP of heat pump. Now we subtract 1 minus 1 from this, we will get the COP of what? Refrigerator. So in this way, 0.25, the answer was 0.25 is the answer for what? COP of refrigerator. Now moving ahead, the second thing which is important, they have explained that what the efficiency is, and if we are going through these two things, then there will be COP. So they have determined the COP also of refrigerator. Lower temperature will be in the numerator, and for heat pump, the higher will be in the numerator, and refrigerator COP plus 1 is called COP of heat pump. They have explained. Now, in the what else is there, that all the air fuel system or whatever system is there, we used to have a one ideal cycle also, because in engines also we have gone through one ideal cycle that is called Carnot cycle, and for patent also we used to go through the this fact that no system can have efficiency greater than Carnot. So when we reverse the Carnot, we get the ideal cycle for refrigeration. So this is the ideal cycle for refrigeration. In this we can see the starting is the compression, then again compression, twice the compression, and twice they have given the expansion. First compression is isentropic, means entropy will remain same at both the point S1 is equal to S2. Second is isothermal, temperature will remain same. Then again isentropic, entropy will remain same, and then isothermal, the temperature will remain same. So in this way the cycle is being explained. We know that whenever there is isentropic process, no heat is added or rejected. So we will go through only these two processes only. And the area of TS diagram will be determined, means when we want to know the heat absorbed during this process, then we will determine the area under this curve, means length into breadth. This thing, length into breadth, will be used. So what they have used, only these two processes they have gone through, 2-3 and 1-4. This is the 2-3 process. In this, what heat is released, rejected, the area they have determined, and the second process is after 2-3, the second process is 1-4 they have gone through. Going through the fourth process, they have determined that what area is. Area, we know that if we want the area below 1-4, then the height we know, height is given by, height they have given by T4, and the breadth they have given by S2 minus S1. So simply they have determined the S2 minus S3 what they have used. So simply they have determined the area, and heat absorbed minus rejected upon heat absorbed upon heat absorbed minus rejected, that is the burden they have used, and finally they have determined this formula, that is lower will be the numerator, we have gone through this, and high minus low will be the denominator. So in this way the COP of refrigerator will be determined. Now we are coming through the numericals, because the temperature limits of reverse Carnot cycle is also a part. So you should go through these points also, that what will happen, because certain questions are asked on decreasing higher temperature, because if the we decrease the higher temperature of the system, then the denominator will automatically get decreased and COP will increase. Or increasing the lower temperature, means fridge inside temperature of fridge should be increased for increasing the COP. So the temperature limitations also they have given, that what limitations are there in temperature. Now one by one we are going through the questions also. So starting with the first question, it is asked in November 19. So a question you can see. The question is the refrigerating system operate on reverse Carnot cycle. It is question 2.6 from Khurmi. So we should go through the Khurmi also. The question 2.6 where it is mentioned. Initial question you can see by yourself, because limited question are solved over here. The question is 2.6. The same question is asked in November 19. A refrigerating system operate on reverse Carnot cycle. The Carnot cycle is reverse. Mean first point will be over here, because basically the first point is here in main cycle, but in reverse it is here. So reverse cycle we are going through, first point will be here. The higher temperature is 35, means both the temperatures what they have mentioned are 35 plus 273. and the lower temperature is -15, means this temperature what they have mentioned, both the temperature are same. This is -15 plus 273. The capacity is 12 ton. We have to convert it, the ton terms into kilowatt or kilojoule per minute. Determine the COP, heat rejected per hour, and power required. We know that the COP, initially the COP is not a single formula, it is two formula. This you should learn for always. You have to learn that this is not a single formula, this is two formula. With this formula we can determine two unknown simultaneously. One formula is T low upon T1 upon T2 minus T1, means low upon high minus low. This is T1. And the second formula is refrigerating effect, means what refrigerating effect is we have observed upon work done. So these are two formula instead of one. We know T1 is given in the question, T2 is also given in the question, so we can determine the COP. So COP, this can be determined very easily because nothing was there in the COP of the system. I have told you that COP is not a single formula. The second formula I have told you that the second formula is refrigerating effect upon work done. So same thing they have used, refrigerating effect upon work done they have used, refrigerating effect upon work done they have used, and from this what they have determined, the refrigerating effect, means upon work done they have determined, because refrigerating effect is is given in the question, that was 12 ton. So 12 ton they have initially converted into kilojoule per minute. Refrigerating effect was known. This refrigerating effect was already known. The numerator was known. W is to be determined and COP was also known. So W they have determined. And the heat rejected, we know that whenever we draw a system like this, the heat rejected is summation of heat absorbed, refrigerating effect, plus work done, both are added, and this much heat is rejected. So both are added and this much heat is rejected. I have shown you in the figure also that what amount of heat is rejected is the summation of the two, means is being shown over here. The summation of the two is rejected, and this is being shown over here that summation of the two is rejected, that Q1 plus WR, and the heat rejected is Q2, summation of the two. So that's why in this question, in the particular question which we are solving, they have added the two terms and this particular heat is rejected. So they have added the two terms and this particular heat is rejected. We know that work done, whatever the work done is given, that is divided by 60 to know the work done in kilowatt. So this question was asked. The main thing is that this question was asked twice, means in the November 19 also it was asked, and June 17 also this question was asked, the same question. This is being shown over here. Now moving to the second question, that if we solve another question, that is of May 18. If we go through the May 18 question, a reverse Carnot cycle has COP of 4. Determine the temperature ratio of the cycle. If the power consumption is 7.5 kilowatt, determine the refrigerating capacity in TR. This is also a simple question because we know that COP, what COP is? COP means T1 lower temperature upon high minus low. If we somehow determine, because there are two unknown, only COP value is given. The COP value they have given the 4. The value of COP they have given, that is 4. They have not given T1, T2. So we will divide the complete term right hand side by T1, means divide by T1, divided by T1, and denominator will be also divided by T1. So what will happen? T1 by T1, we will get 1 in the numerator, and in the denominator we will get T2 by T1. We will get T2 by T1 because T1 will go inside, T2 by T1 minus T1. equal to, what was the given the value? COP 4. So from this equation we can easily determine single unknown, that is T2 by T1. This is called temperature ratio. They have asked also what is temperature ratio. Now second thing what they have asked, if the power consumption is 7.5 kilowatt, determine refrigerating capacity. I have told you earlier also that COP is not a single formula. The formula is COP is T1 upon T2 minus T1, and thereafter it is refrigerating effect upon work done. So work done they have already given. The work done they have given in kilowatt. In the power they have given 7.5 kilowatt. They have given the value. 7.5 will be put for W. And refrigerating effect we have to determine. And the COP is already known, that is given 4. So these two things are known. Refrigerating effect is to be determined. So this can be easily determined in kilowatt, and by dividing it by 3.5 we will get the value in ton. That was required. So it is also a simple question. If you want I can solve, because W into 4 means 7.5 is W into 4. So what will be the value? Again we are starting the calculator. 7.5 into 4. So this much kilowatt of cooling effect we are getting, that is 30. But what about ton? So we will divide it 30 kilowatt by 3.5 because it is in kilowatt. So in ton we will get 8.6 we can take, because 8.57 they have mentioned. 8.6 the refrigerating effect we can get in ton. So in this way we can solve this question. And moving ahead with the book also, because one question is very much popular in this, that is of fish or fruit. The question is this, that is 2.10. A cold storage plant is required to store 20 tons of fish. The fish is supplied as 30 degrees centigrade. A specific heat of fish is also given. A specific heat of fish below freezing point is 1.26. Fish is stored in cold storage at -8, means inside the fridge, that is inside the fridge or inside the room or inside the cold storage, the temperature is -8, means lower temperature is known to us, that is -8, and outside temperature is 30, means the temperature where the fish is supplied is 30, so higher temperature is 30. So in this way we will firstly determine the COP. Freezing point of fish is also given. Now what they have asked is the capacity of the plant. So we will initially determine the COP. The COP is determined, its value is much higher, that is 6.97. They have given the ratio of COP, that is actual COP, the relative COP they have given, actual COP of the plant is 0.3 times, means only 30% of theoretical COP. So this COP is to be reduced. It will get reduced. The COP term is to be reduced, and it will get reduced. And by multiplication by 0.3, the new COP is very less. We know that the COP is not a single formula. It is 2 formula, means one is temperature ratios what we are getting. So first thing is the temperature ratio what we are getting. And the second thing, what is refrigerating effect upon work done. So in this, what they have done, the COP they have determined as 2.091. If we multiply COP with the work done, then we will get refrigerating effect. Same thing they have done, COP and work done they have multiplied, and refrigerating effect they have obtained, because in Khurmi the refrigerating effect was easily obtained in kilojoule per second. They have changed in kilojoule per minute and then divided by 210. If we divide kilojoule per second, means 156.8 by 3.5, then also we will get this 44. Means if we use calculator, and the term was 156.8, 156.8 divided by 3.5. If we are using some other book, then 44.8 and 44.8. So we don't require to convert it uselessly into the kilojoule per minute. We can directly divide by 3.5 and get this term. But the Khurmi has maintained that system that kilojoule per minute they have used. In this way, we get the cooling capacity of the, means two things we have determined, the cooling capacity of the plant they have determined and the COP. Now they want the time required to achieve the cooling, the second thing they have asked. Because the fish, whatever liquid we used to freeze, because whatever liquid is there in the world, what used to happen in the liquid, if here the temperature is shown, I have drawn this curve several times. If here the temperature is shown, I am drawing this curve over here. If here the temperature is shown and here the heat is shown, and we should firstly know the freezing point of fish, that is given -4. So if we draw the diagram of fish, means the heating of fish, if we show the here the temperature and here the enthalpy, and if we start heating the fish, because fish is to be maintained at -8 degrees centigrade. The -8 is the temperature which is being shown over here. This is the -8. Start heating the fish, and fish has now reached to the new temperature. Now the temperature what is reached is 4 degrees centigrade. This is the 4 degrees centigrade temperature, and -4. Sorry, -4 is the temperature of the freezing point. From -8 to -4, it is being heated. It is solid state. Now the melting point is -4, so fish will convert from -4 ice to the -4 liquid. Horizontal line will be obtained. Now again the fish will be heated, so its temperature will change from -4 to the final temperature, that is 30. Means this much heat is to be removed. Means we have to first cool it from 30. First we have to cool it from 30 to -4. Then from -4 to -4 again, and then from -4 to -8. Means 3 formula of heat will be used, because we have to cool the fish from 30 to -4, -4 to then -4, means -4 liquid to -4 solid, and then -4 solid to again -8 solid. So 3 formula of heat removal are to be used. These are the 3 formula which are shown over here. For 2 formula, the temperature change is there, means 30 temperature to -4 temperature they have shown, 30 to -4 they have shown, then again -4 to -8 they have shown over here. So -4 to -8 they have also shown. But for this case, means when there is no temperature change, latent heat is there. The latent heat is given in the question. The latent heat what they have given is 235. For this ml formula we will be used, because I have told you that for heat only 2 formula are used for any liquid. That is, one is MCP delta T and another is ml. MCP delta T will be used for these cases whenever the temperature change is there, and ml will be used whenever no temperature change is there. All the 3 heats are to be added, because this much heat is to be removed from the fish. We have to remove this much heat from the fish. Means first we have to cool from 30 to -4, then -4 to -4 liquid to solid, and then -4 to -8. Then again -4 to -8 is the final temperature they have mentioned. Means 30, -4, then again -4, and this one is -8. This temperature is to be done. So this much heat is to be removed. So they have added the three terms. They have added that this much heat is to be removed, and heat removed by the plant per minute is also known to us, because what heat is removed by the plant per minute is known to us. So by dividing this by this, we get the time in minute, and we convert it into the hour. So in this way we know that what time is required for cooling, because whatever the question is, whether it is a question of ice, whether it is a question of fish, whether it is a question of fruit, main thing is that you should know that from which temperature to which temperature you have to cool, that is 30 to -4. Then that temperature it will start freezing, and then from -4 to, then from -4 it has gone to the freezing point, it has gone to the solid state itself. So this type of cooling is achieved, means this type of cooling is achieved. Temperature is changing, then constant, then changing, constant, changing, constant and changing. So this you should know, and this we have to solve by like this. I will cover more questions on this because after this we will cover up the Bell-Coleman cycle also. So go through this question. If any queries are there, then please do ask. Thank you.